Is this thing on? I think it is. It is, because I just paused it and started it again. Sorry about that. I didn't get like the beeping noise that I usually get when it starts. All right, lesson 21, graphing linear inequalities in two variables. So what we've been doing so far in the inequality part of this lesson is talking about inequalities in one variable. Like 3x is greater than 12. Therefore, x has to be greater than 4 to make that a true statement. Okay, that's one variable because there's only one variable there. Now we have two variables, which is like x and y. Because with x and y, we can graph on the coordinate plane, right? Okay, so here's an expression, 2x plus 3y. Decide if the values in each ordered pair make the value of the expression less than, greater than, or equal to 12. Those are our options. Hold on a second. Sorry, someone needed something, so I had to pause. All right, so we're doing this. Let's just rewrite this equation a few times. So remember ordered pair xy. So we're doing 2 times 0 plus 5 times 3 is 15. 15 is greater than 12. And then we can do 2 times 6 plus 5 times 0. That's gone. 12 is equal to 12. And then we have 2 times -1 plus 3 times -1. -2 plus -3 is -5. That is less than 12. And then -5 times, nope, let's write it in the right order. 2 times -5 plus 3 times 10. That would be -10 plus 30 is 20, and that is greater than 12. Okay? So what we did is, in the coordinate plane, we found 0, 5, um, 6, 0 is somewhere over here, -1, -1, and then -5, 10. We found if these four ordered points, ordered pair, were greater than, less than, or equal to a expression in two variables. All right? So we found that out by substituting and evaluating. Okay, so solutions and not solutions. Here are 4 inequalities. Study each inequality assigned to your group and work with your group to find some coordinate pairs that represent solutions. We're going to say represent solutions is going to be in green, and some coordinate pairs that do not represent solutions. And then plot both sets of points. Either use 2 different colors or 2 different symbols like X and O. Plot enough points until you start to see the region that contains solutions and the region that contains non-solutions. All right, so we're going to take this first one and we're going to find some ordered pairs that make this inequality true. X is greater than or equal to Y. So let's do this. 1, 1. Is 1 greater than or equal to 1? Yes. How about over 4 up 2? Is 4 greater than 2? Yes. If we do this ordered pair, let's say that's 6, 4. Is 6 greater than 4? Yes. How about 6, 1? Yes. 3, 1? Yes. 8, 6. Really hard to see. It's kind of small. How about if we did 2, -1? Is 2 greater than -1? Yeah. How about 4, -6? Is 4 greater than -6? Yes. How about -2, -4? Is -2 bigger than -4? Yes. All right, let's switch to another color, or we're going to be doing this forever. Over 1 up 2. So that'd be 1, 2. 1, 2. Is x1, y2 a solution? No. Okay, so over 2 up 4. Is 2 greater than 4? No. Okay, all of the dots up here are going to be a no. In fact, let's do some negatives. -2, +4. No. -6, positive anything. This whole area is going to be a no. Just like this whole area, this quadrant will be a yes. So all these are going to be no's. Any ordered pair in this area. Okay? Any ordered pair in this area. Cool. All right, next, not quite as easy. Let's do some greens. All right, so let's test a point down here. Well, let's do positive, positive first. 2, 2. Let's test it. Sorry, somebody came in again. So we're going to test 2, 2. So I'm just going to write it down because this one is a little bit harder. I'm going to plug 2 in for y and see, is that greater than or equal to -4? -4 is equal to -4, so that is a good one. How about 4, 2? If I do 4, 2. So -2 times y is greater than -4. Okay, we didn't change the y value, so really anything along this line. And this line, because the y value doesn't change, I can change the x value all I want, but I know that's all going to be true. Now let's try 2, 4. 2, 4. -2 times y greater than or equal to -4. So that'll be -8. Is that bigger than -4? No, it's not bigger than -4. That is smaller than -4. So we want all of that to be in red. So I would think anything along this line will be in red. In fact, anything above this will continue to be in red. Let's try -2. So we have -2 times -2 greater than or equal to -4. That is 4. Is 4 greater than or equal to -4? Yes. So all this down here will also be in green. Okay, we're going to stop there and do the next thing that it's asking. Plot enough points, see a region, look for a pattern describing the region. Okay, so my pattern is actually, look at me drawing that amazing line, except I wanted that amazing line to be in black. You guys looking at my face? I'm in serious concentration mode. Okay, green is a solution. Red is not. And we're going to talk about this stuff in a minute. Cool? All right, so here, green is a solution. Red is not. And my line is solid. Okay, when you are solving solving inequalities with two variables, your solution isn't an equation. Okay, it's not an inequality equation. Your solution has to be a graph. It's very important that you know how to make your graph. Your solution has to be a graph. Okay? Goodness, if we did this one, let's just do it really quick. Any ordered pairs. So I'm going to pick a positive. 3 times 2, is that less than 0? No. So that would be red. Over 2 up 2. Let's do another one. Let's do a negative, negative. Negative 2 comma negative 2. 3 times negative 2 is less than 0. That is true. So that has to be in green. And then let's do a negative positive. Negative 2, positive 2. So 3 times negative 2 less than 0 is true. So negative 2, positive 2. And then let's do the other one, 2, negative 2. So 3 times 2 less than 0. No, that is not true. And I did 2, negative 2. All right, I could plot more points, but I'm going to see that this would be my answer. Everything over here is a solution. Everything over here is not a solution. And then this one. First of all, so I'm going to do this one a little bit different. I'm going to write an equality and then put it in slope-intercept form. Y equals negative x plus 10. So I am in concentration mode again. I made that dashed on purpose. I did. All right, I'm going to test 0, 0. 0 plus 0 greater than 10. Is that true? No. Okay, so that means all of this I would shade in red. Let's test 5, let's see, 2, 4, comma 8. 2, 4, 8 is right here. Let's test 2, comma 8. Oh, that's not 2, comma 8, sorry. 4, comma 8. There we are. 4, comma 8. So 4 plus 8 is 12. Is 12 greater than 10? Yes. So I'm going to shade everything over here. All right, when I shaded it green, that means every single ordered pair in that green area is a solution to that inequality. Every single ordered pair. I picked enough ordered pairs, put enough dots in here that I made it all green. Every single ordered pair in that shaded area is a solution to the inequality. And every single ordered pair in this area is not a solution to the inequality. Okay. Sketching solutions to inequalities. Here is a graph that represents the solutions to the equation x minus y equals 5. Now, this equation, every single ordered pair on that line is a solution to this equation. Every single ordered pair on the line. Okay, I could put infinite numbers of dots that make up this line, and every single dot represents an ordered pair, and every single dot is a solution to this linear equation. All right. So here, if you see, I've got four inequalities, with all the very same foundation of x minus y equals 5. So I can actually draw this line 4 times. And I'd love it if you guys would notice I'm drawing a dashed line and a solid line, and maybe you could figure out why I'm doing that. Maybe you can see the pattern. Why am I doing that? Let's not use green. Do you see the pattern? Why did I use a dashed line? Why did I use a solid line? Okay, why? All right, let's start graphing. I know that this is my linear equation, but I need to graph the inequality. So I want to know if the ordered pair 0, 0 is a part of this, as part of the solution to this inequality. So I'm going to test 0, 0. 0 minus 0 less than 5. Is that true? Yes. So I can shade every single ordered pair on this side of the dashed line is a solution. I shouldn't have used red either. All right, let's double check. Let's test 5 comma negative 5. So x is 5 minus a negative 5 less than 5. I add these together. Is 10 less than 5? No. So every ordered pair on this side of the line is not a part of the solution. All right, let's do the same thing. I'm going to test 0, 0. 0 minus 0 less than or equal to 5. Is 0 smaller than or equal to 5? Yes. Now let's test 5 comma negative 5. 5 minus negative 5 less than or equal to 5. No, that is false. So that needs to be a part of not the solution. All right, what if I test a point on the line? Let's test, I know that 5 comma 0 is on the line. So if I do 5 minus 0 is less than 5, is 5 less than 5? No, which is why we have a dashed line. That means all of the ordered pairs on the line are actually not a part of the solution. So we signify that with a dash. Now if we do this equation, 5 minus 0 is less than or equal to 5. Is 5 less than or equal to 5? Yes. And that's why we have this as a solid line. That means every ordered pair on this solid line is a solution to the equation. All right, let's try the same ordered pairs. 0 comma 0. 0 minus 0 greater than 5. That is false. So that means that 0, 0 is right here. It has to be a part of the not solution. And then if we test 5 negative 5, 5 minus a negative 5 greater than 5. Is 10 greater than 5? Yes. So this has to be a part of the solution. And we're going to get the same thing over here. Oh, that didn't. What happened there? Okay, makes sense? All right, so for each graph, write an inequality whose solutions are represented. This right here is a line on my x-axis. X equals, it looks like 3. This is a line, x equals 3. Now that's an equality with one variable. We need an inequality. So really we want x, all of the numbers greater than 3. Now that line is dashed. Therefore, we know that it's just a greater than symbol, not a greater than or equal to symbol. All right, this line, I'm on the y-axis, so this is a line y equals, well, we'll write it here, y equals -2. That's an equality. But I need to write the inequality. And I've shaded everything smaller than -2. So really we're at y is less than or equal to -2. And we say equal to because we're a solid line, where this one is dashed. Solid. Cool? So that's my answer, and that's my answer. Okay, this right here is the line y equals x. Now it's dashed, let's see. Not sure how to shade it. So if I pick a point like 0, 6, 6, and it's shaded, it needs to be part of the solution. 6 is greater than or equal to 0, and that's my y, x. So this should be a greater than or equal to. Ooh, I made a mistake. Just greater than, because we are dashed. So it's just greater than. Okay, I can also test a point down here, like 6, -6, and make sure y is -6, greater than 6, that is false. So we don't want that shaded in the area. So this one's going to be the opposite, but it needs an equal sign because it's solid. And let's test a point. We can test this point, 0, 6. 6 less than or equal to 0 is false. And that's fine because it's not in the solution. And then test this point, 6, -6. Is -6 smaller than or equal to 6? That is true. So that needs to be in the solution. Okay, are you ready for more? We talked about this a little in the last lesson. If you want a little bit of a challenge, it sounds great. Trying to find it. All right, I'm going to push pause and put some answers in there so you can check them. All right, feel free to push pause and look through this and let me know if you have any questions. And there's your summary. Okay, oof. But you have this in your notebook. Okay, your lesson summary, which is really fantastic explanation of what we just did. Great review. Good job today.